Welcome everyone. So in this session we are going to discuss another DSA problem which is titled as find k closest elements. So let's try to understand the problem statement. So you will be given an integer array, also you will be given an integer number k, another integer number x, and what you are supposed to do is that x is our target. So whatever the elements which inside this particular given list that is closer to this given x has to be identified, and the one who nearest to this particular given x, we have to pick those. And how many of those should be picked? That is what this number represents. We have to pick the 4 numbers that is near to the given target x within this ARR list. And if there is a tie, for example, suppose if 2 and 4 which is equidistant from 3, like here the difference is 1, here also difference is 1. If there is a tie, in that case we should pick the lower number. So that's how we need to do. So how can we do that? How can we pick 4 numbers which are near to the target 3? So what would be that? So you can see that 3 himself will be picked here in the output, because the distance from 3 to 3 is obviously 0, and 2 and 4 are the next candidate. So both will be picked. In this moment we are only picked 3 elements, but we need to pick 4 elements. Now the question is, which one should we pick, 1 or 5? There is a tie between them, because 3 to 5 the distance is 2 units, and 3 to 1 also is distance is 2 unit. In that case there is a tie, so we should have picked 1, and that will be picked, and the output whatever we are going to mention will be in sorted order. Because one thing which I mentioned here is that the given integer list AARR will be in a sorted fashion. So how can we do that? So there are 3 sets of information. One is the given list, another is the numbers we need to pick from the list that are closer to the target x. How can we do that? So one of the brute force idea is to sort all the elements, okay, using the rule which is mentioned here. What is the rule? The rule is that sort it based on the absolute difference between this particular target. We need to sort in this particular fashion. So for that we can use lambda expression to write the code. And there is another better way. So first, like, discuss this expression of sorting using lambda expression. So how can we do that? So first let me try to write the class definition and all. Class solution define, this is a method inside this thing, find close elements. What are the arguments given? An ARR is given, which is a list of integer, and another k is given, which is an integer, and the target x is given, that is also an integer, and we need to return another list. So that's what we need to write. So the return would be another list of integer. So this much if you will to write, you have understood the question. And what we want to do is that we need to sort it using the rule which is mentioned, that is based on the absolute difference between x. So for that, let's use to store another array ARR2. Let's sort it. It will be sorted what will be sorted? ARR will be sorted in a particular rule. And how can we express the rule? For that we are going to use key lambda expression. So this is similar to writing a function but in a single line. Key equal to lambda, and we have to choose num such that, so we are going to store like sort based on a tuple fashion. For example, first we will sort the distance and then the key. So this is how we are going to like sort. For example, in the case which we had discussed, if the distance of 1 and 5, so that was initially the distance is 2 but the key is 5, and the distance is 2 and key is 1. So here if it's sorted it would be 2 1 2 5. So this way we need to get things sorted. That's why we are using to store as a tuples. So let's store like that. First key would be absolute value of num minus x, and whatever be the corresponding number that will be also like stored. And we need only k elements, and we just need to store it into another list like result equal to ARR2 ranging from, which is also need to be sorted, we should not forget that, sorted ARR ranging from first element to the kth element, then just return the result. So what is the time complexity here? Here we are like finding the absolute difference, distance, this thing is happening, and sorting is also happening. So in this step the time complexity would be, to find the distance it would be n, and sorting would be n log n, and here again we are sorting, for that it will be again n log n. So in generally we can just assume the entire complexity of solving the problem in this particular fashion would be having the time complexity of n log n, and the space complexity would be order of 1. So that's it. So is there a better way to solve it other than this thing? Yes, there is a better way. We can use pointer methods, and we can also utilize the fact that the given integer is sorted. And how can we do that? So this is all about finding a window. For example, here also after sorting we are returning a window from 0 to k. So this is all about finding the right window that contains the elements nearer to this target, and the window width should be equal to the k. So that way we have to think. So if this is a given array, let's try to explain that thing. So better solution, if a given an array, if this has length of let's be n, and the window size is also given in the problem, that is k. So we have to find where the window is starting. If we know where the window is starting, for example, if the window is starting on left, the window is going to end at left plus k. So left to left plus k, we need to identify that. So we are going to identify left, so that is enough for us. So let's try to like optimize this particular approach using the pointer method. So I am sure that if I want to identify my left, okay, it can start from here 0th indices, and it can go up to the length of given array minus k, because if this is the left, then left plus k would be the last element. So within this particular window, I can try to search for the left. I hope you understood. This is a subtle point. If you understood, that would help really a lot. So what I am going to do, if this is a given array, I am going to choose the window in which I need to choose the left. So I am going to assign the left here and the right somewhere here. The right is nothing but the length of the array minus k. So this is the range I am going to start, and then I am going to find the middle point. I am going to find the middle point. Okay, then I am going to see where the target is nearer to, where the target nearer to this region or the target nearer to this region. Based on that, I am going to update the left and the right, and at the end, once the left, I will do this up to left less than right. Once this is over, I have identified my left. I just need to return whatever the array which is already sorted, starting from the left indices to left plus k. This is what I need to do. I hope you understood, but you will get much more clarity when we try to code this thing. So let's erase this part. The code will give you much more understanding. So let's start with the class definition and all those things. I can just simply copy from this brute force method. Yes, here it is. As I said, this is a pointer, left and right is another pointer. In this window, I am going to find what could be my left. So it can be 0 and right can be up to length of ARR minus k. In this window, I am going to find. And while left less than right, I'm going to find the middle point. Mid is equal to left plus right by 2. Now I am going to identify where the x belongs to, or where the x, which regime the x is going to like seen. For that I am going to check if x minus ARR of middle, if x is somewhere in the second half, that's what I want to know, then this would be positive. Or ARR of mid plus k minus x. If this is higher, if this is higher, that means it belongs to the first portion. If this is higher, that means the x is somewhere in the second half of the portion where we have identified the mid. In that, if it belongs to the second half, we just need to shift the left. So this, in this case, shift the left equal to mid plus 1. Else, if it belongs to the first half, then update the right to the mid. Once this particular iteration is over, we are eventually going to arrive at the starting point of the window we need to return. So we need to return, once this is over, ARR starting from left to left plus k. This k is given in the problem. So this is the solution for find k closest elements. So what is the time complexity here? Here we are iterating only once, and also the point is approaching each other. So in a better ideal case, it would be n by 2. So we can also write the time complexity is order of n. Space complexity, we are not utilizing any extra space, so it would be order of 1. So I hope you understood the brute force method as well as the better solution method. So that's it. So thank you for listening.